Okay, we'll start this question by looking at the forces in the arm of the crane. So we know that the arm of the crane is 8 meters long, and it's got an evenly distributed mass of 500 kilograms. So in the middle, we know that we've got a downward force of 500 G. It carries a mass of 1200 kilograms at some length L. We're told here that L is 8, it's right out at the end. So down here at the end, I've got my force of 1200 G. It's supported by a 5 meter long cable, which is secured 4 meters up from the pivot. Well, that's quite a useful triangle here because we've got a hypotenuse is 5, one side is 4, well we know it's a Pythagorean triplet, so 3 meters along. I've got some tension in my cable. We don't know what that tension is, that's part of the question. And I'm going to give that angle there theta, and we know in this case that sine theta, this is the angle theta, is the opposite over the hypotenuse, so I can just write that sine theta equals 4 over 5. So let's start writing in our distances. I know that here I've got a distance of 3 meters, because that's the side of my Pythagorean triangle. There's another meter there to get to the midpoint of the crane, and there's another 4 meters to get to the end of the crane arm. Now, I've got my pivot point here at the right hand side, and it's worth thinking about, if this wasn't pivoted, what do we think would happen to this end? Well, here, if it was just the tension in the cable, this would swing down, which would make this swing up, so we know there must be a downward force exerted at this place. We also know that this tension pulls it to the left, so this must be pushing it out, so there's a rightward force. Okay, so we're going to call this, we can call it whatever we want, but let's call them X and Y are the two forces which are being exerted by the pivot. Okay, so once we've done that, we can do this in exactly the same way. This is our pivot here, so we're going to start by taking moments about pivot. And if we look at our clockwise moments, I've got 4 times 500 G plus 8 times 1200 G is going to equal, now we need to be super careful here, and let's have a look at Y. The effective distance here is going to be this green line here, where that is a right angle. So I'm just going to redraw this. I know that this is my angle theta, this is 3, and there is my right angle up at the top, and I'm trying to do X. So here I know that sine theta equals X over 3, therefore X equals 3 sine theta, and we know that sine theta is 4/5, so it's going to be 3 times 4/5, which is 12 over 5. So let's go back to our moments over here. This distance is 12 over 5 times by the tension. Simplifying that gives me 2000 G plus 9600 G, which is 11,600 G, equals 12 over 5 T. And that gives us a tension of 47,400 newtons to 3 significant figures. We're now going to resolve our forces vertically and horizontally. X and Y are horizontal and vertical respectively. My two weights are vertical, so the only one that I'm going to need to decompose is T. So here I'm going to have T cos theta That's t cos theta. And up here I've got t sine theta. So let's start by resolving horizontally. I can say x, which acts to the right, is equal to t cos theta. Now I know that sine theta equals 4/5, so let's do my triangle. 4, 5, so this must be 3. So cos theta equals 3/5. So x equals 3/5 times 47,400. Ideally you'll have that stored in your calculator as a more accurate value. So 0.6 times my answer gives me 28,420. Resolving it vertically gives me my upward component is going to be t sine theta equals my downward component 500g plus 1200g is 1700g plus y. So here I've got sine theta, we already know is 4/5, so 4/5 t equals 1700 g plus y. So 0.8 times my original tension minus 1700 times 9.8 gives me an answer of 21,230. It wants the magnitude and direction of the force in the pivot, so we know that here I've got a 28,420 force, I've got a 21,230 force, so I'm going to need to find the magnitude, I'm going to need to find the hypotenuse, so I square them, add them together, square root. And it gives me an answer of 35,500. So the magnitude of the force is 35,500 newtons. The direction of the force then is this angle here. So theta equals inverse tan 21,230 over 28,420. Which gives me an answer of 36.8 degrees. So you should answer that. That's not clear as to what that means. The force is 36.8 degrees below the horizontal to the right.